model. So we teach in lectures and practical session we have this model. So basically the only knowledge, the practicality of learning about ascending and descending tracts is from this model where they just show one section of the spinal cord and then they show the nerve roots. The actual thing that is happening is actually the neuronal pathway, which they only learn theoretically.
We implement the technology of 3D printing in our model. We will start with the spinal section designing with the ThinkerCAD software so that we can design all of the 3D printing that we use in the model. And we convert the design into the macrocura so that it's compatible with other 3D printers. We choose to start from the spinal section, roster it to the brain so it can represent the real life of a neuronal pathway.
From the printed section, we assemble it to mimic like a normal human being. So we have the cervical section, we choose 3 sections and then followed by the brainstem arrangement, which is the open medulla, closed medulla, pons, midbrain, and finally the brain. Conscious sensation, for example, in our model we have lateral spinal thalamic tract. Usually in conscious perception, we have 3 order neurons, which is demonstrated here. The first order neuron is actually the peripheral nerve. Okay, if I say, for example, in the C7 over here, you have the peripheral nerve. For the lateral spinal thalamic tract, it will synapse on the same level to the second order neuron. Then followed by synapse of the second order neuron. You will decassate, means it cross over. It cross over on the same level and it ascends upwards on the contralateral side until it reaches the thalamus of the brain, and then it will synapse with the third order neuron to be perceived as a sensation in the somatosensory cortex. So each of the connector over here is the location of the synapse. We also prepare the wires to be short wires. You can see the connector, short black connector over here, so that they can assemble where is the location of the first order, second order, third order neurons, and also where is the location of the decassation. This is the basic mechanism of the lateral spinal thalamic tract. What we expect from the students is 2 things. Number 1 is how to assemble the tract correctly. So they need to know the area of decassation and also the 3 order neurons that I mentioned earlier on. So they will be given with a lot of wires, short wires, so they have to assemble from the peripheral nerve, where does it go to. If the assembly is correct, which is very selective for each dermatome, you have prepared a closed circuit for each dermatome respectively. So if the connection is correct, the light will turn on. Alright, but if it's wrong, it will not turn on. Okay, number 2 is for them to demonstrate or to elicit syndromes like peripheral nerve injury or spinal cord sections. Spinal cord injury, we call it full section or hemisection. Alright, so I'll take one of it. So say that I want to choose peripheral nerve injury. So I will just remove a first order neuron of C7 in this case. Alright, so when you remove one wire of C7 over here, then you look at the sensation, which is set by the switch off of the light bulb. So in this case, if you look over here, there will be ipsilateral, which is on the same side, C7 loss of sensation, dermatome. Alright, while there is perseverance of sensation in spinal cord above and spinal cord below. So it means it's something to do with a peripheral nerve injury or first order neuron injury. And then another example is spinal cord hemisection. So I choose in the same section. Alright, so if there is a hemisection, means there's a half injury of the spinal cord. So if I choose again C7, I just have to disconnect the wire, whatever wire that is in that half of the section, and then they will again demonstrate which area there will be loss of sensation. In this case, there will be contralateral loss of sensation on the same level, C7, and the level below it, C8. But there is a perseverance in the sensation on the level above the vision. So from here, they will learn which is contralateral, which one is ipsilateral, and where is the suspected site of injury based on the symptoms.